Hey, hi again. So hopefully, you've already watched the 8-1 lesson to check your work. And now I'm going to be going over lesson 8-2. So the first thing is reading your I can statement. So I can find and explain addition patterns. So we're just going to go right into it. So the solve and share, it says shade three sums that are next to each other on the addition table. Add the first and the third sums you shaded. How is the total you get related to the second sum you shaded? Is this true for other sums? So sounds like they're asking you like a whole lot of stuff, but actually it's super simple, I promise. So I'm gonna go lighter number. So I'm gonna shade in the 5, the 6, and the 7 right here. So I could have picked any three numbers next to each other. I just chose these. So the 5, the 6, and the 7. So my three numbers are 5, 6, and 7. So what they ask you to do is to shade or is to add the first and the third numbers together. So I'm going to add my 5 plus my 7, and that gives me 12. Hopefully you said it or you were able to add it. If not, that's okay. And they want to know how are the 12 here and the 6 over here related. So when we're talking about the relationship between the two numbers, how are they related to each other? Let's think about what things we already know about 6. I know that half of 12 is 6, and then I know that 6 doubled gives me 12. So for this example, I can say that the three sums I shaded in that are next to each other, when I add the first and the third sums, the total of those sums is doubled. Is the second sum that I shaded in, so in this case 6, doubled. So I'm gonna give another example in a different color. Let's do orange. So I'll do the 11, 12, and 13 right here. So my three numbers are 11, 12, and 13. So again, they want me to add the 11 and the 13, and that would give me 24. And again, using my double stacks, using what I already know, I know that half of 24 is 12, and that 12 doubled is 24. And also those kind of look like bird feet, but that's totally okay. So they just want you to hopefully realize, and we'll talk about this in the look back section at the bottom as well, that any three numbers that you shade, so it doesn't matter if you shade in the 3, 4, 5 here, or if I shade in the 9, 10, 11 here. If I add the first number that I have shaded and the third number that I have shaded together, if I double the middle number, it's going to give me that sum. So if I were to do right here, the 10, 11, 12 in the blue right here, I would get 10 plus 12, so 22. But then if I double 11, it's going to give me 22. So is this a super useful strategy? If you're using a number addition table like they show you here, if we're using one of those all the time, then yes, I think that then it would be a useful strategy to try and master. But If we think about it, how often when we're adding do we have this addition table in front of us? It's not that often. So I want you to be able to explain this strategy, but it's not something that I expect you to use all the time. And I know we've talked about strategies before in class when it comes to multiplication. And I'm also going to resell this right now. Multiplication and other operations like division and subtraction, even. Yes, it's important for you to be able to understand these strategies, just in case you do decide to use them. But at the end of the day, it's your decision what strategy you are using to add and to subtract and to multiply and to divide. So whichever one you're most comfortable with. So if this is a strategy that you're not as comfortable with, that's okay. Now the bottom part says, explain what you did to test if the relationship is always true. And for this, it's just the work that I had shaded in like the blue on the table above before I erased it, obviously. So if you want to go back a couple seconds or a little bit, that's totally fine. After I'm going to explain this just to double check what I'm saying. So basically, I repeated the same steps for different sums and compared what I found. So I shaded different sets of three numbers and tried to see if the rule that I came up with that the book was helping me with was true. And it ended up being true. So is it always true? Yes, it was always true. And I found that it was always true by going back and double checking my work and shading in different sets of three numbers. So on the next page, so on page 410, or sorry, 412, sorry, 412, it asks, how can you find addition patterns? So yeah, remember this is just the example box. There's no work that you need to do as long as you're reading through this in your packets every day. So it says, Helen notices a pattern in the addition table. The sums change between even and odd as she reads across a row or down a column. Explain this pattern. It says, remember, an even number can be shown as two equal groups. So it can be written as a double. An odd number cannot be shown as two equal groups. So again, when we're talking about equal groups, that kind of makes me think of multiplication. And hopefully it did for you too. If not, it's okay. But the equal groups, we know that if it's an even number, it can be divided by two. It can be put into two equal groups. If it's an odd number, it cannot be divided by two. It cannot be put into two equal groups. So it's just what they're saying here, but relating it back to addition. Box B says, think about even and odd numbers. Oh, sorry, going back up, explaining this pattern. For up here, it has completely missed that part. Sorry, guys. For the explaining the pattern, the sums change to even and odd as she reads across a row or down a column. So it's just looking at the add-ins, and the add-ins are going to be all of the numbers in blue, and just looking at it. So if I look here, I'm adding an even plus odd, so that gives me an odd. If I'm adding an odd plus an even, it gives me an odd. So it's just going back and forth, and also all of the sums shaded and in green are all odd. Okay, so none of them can be divided by two, and all of the sums in white are even. So just think about even and odd numbers. Now moving on to box B. An even number of things can be paired. When you add one to an even number, you get an odd number. So they show you here, they show you 8 boxes right here. And then they add 8 blue boxes, and they add 1 green box to it. And they're showing you them that gives you an odd number. And you can also just see here, there's this blank space missing. There's something wrong. So even if you were to multiply 2 times 4 to find out how many blue boxes there were, you still have this 1 green one on the end that you would have to add to it. Then it says when you add 1 to an odd number, you get an even number. And now we have all our blue boxes because it's an even number overall. So we have our 10 boxes total. And a little speech bubble says, as one more is added to each sum on the addition table, the sums change between even and odd. So if you look over here in box C, just as the example, instead of moving back up to the bigger addition table, when it's saying the sums change between even and odd, if I'm just adding one more, I'll go even, which is 8, odd for 9, even for 10. And even moving down, it's all going up by 1. So odd 9, add one more is even 10, add one more is odd 11. I can do that for 6. I could go up and do it for the entire table up here if I wanted to. If you want to do that, you totally can. That's your choice. And now just focusing on box C, it says you can use the associative property of addition to explain. So as you read across or down in the addition table, one more is added to the sum each time. For example, 4 plus 5 is one more than 4 plus 4. So they're showing you here that 4 plus 4 right there, plus one more, is the same as 4 plus 4 plus 1. So you're still going to be, that this one is going to equal 4 plus 5, and this one would be giving you 9 as your total. And if you, when you do this one right here that I'm highlighting, or just going over in blue, you're still going to get 4 plus 5 for here, and you're going to get 9 as your answer. So it's just, again, telling you a more or less a longer way of solving what is one more, one less, which is fine. It's a good explanation to have and to know, but as long as you are comfortable adding the numbers together in whichever order they give it to you, then using this strategy is your choice. For the convince me section, it says, Sebastian said that an even number plus an even number is always even. Is Sebastian's pattern always true? Explain. So the answer is yes. Each add-in, so again, each number in the add-ins, remember on the addition tables are all the numbers in blue. They're going to be all the numbers in blue. If it's a tiny addition table like there is in box C, or if it's a larger addition table like there is in box A. So each add-in can be shown as two equal groups, so the sum can be shown as two equal groups. And also, if your explanation has an equation in it, so if you say yes because most of you hopefully know by now, because it is March, that I'll accept work and an equation as part of your explanation if that's better suited for you. If you're more comfortable just showing an explanation, then that's fine. So if you have down here something like yes, because, and then 2 plus 2 is 4. You know that 2 is even, you know that 2 is even, you know that 4 is even. Or if you were to do 4 plus 8 equals 12, 4 is even, 8 is even, 12 is even. If you have an equation as part of the explanation, I will definitely accept that. And if you were to say yes because and then showed me even what an even number plus an odd number would look like, if you thought that that was helpful to your explanation, then that's okay. That's fine with me as well. Okay, and moving on to page 413, the last one we're going to go over in this video. The first one in guided practice is do you understand? So is the sum of two odd numbers odd or even? Explain why the pattern is always true. So is the sum going to be even or is the sum going to be odd? So if I were to add 5 plus 7, I did this one before already, the same addition equation, what would I get as my answer? Hopefully you said 12. And is 12 even or is it odd? Okay, 12 is even. I'm going to put an E there. And then if I were to add 3 plus Let's do 9, another odd number. I'm going to actually get the same sum. But what would my sum be? My sum would be 12. And then is 12 even or is it odd? It's even. And yes, I got the same sum, so I could have done a different equation overall to show you a different sum, but is the answer always even or is it always odd? Looking at this here, I can see that 12 is even, and then my other answer happened to be 12 as well, and that's also even. So it's always even. And explaining why the pattern is true, again, you can use an equation for this. So you could have shown me work, something similar to this. If you did, great. If not, that's okay. If you put a sentence, something along the lines of the 2 extra ones in each add-in. So the 2 extra ones in each number. So like the extra 1 in 5 plus the extra 1 in 7 give us 2. So the 2 extra ones in each add-in pair up to make another pair in the sum, so the sum is even. So kind of a tricky explanation to give in a sentence form. Knowing most of you, if you completed this the way that you would have in school, you used an equation. So we're still gonna move on to number 2. And I know the explanations for some of these can be kind of confusing, and that's okay. As long, again, as you can add them and show equations to prove your work, then we're good. So number 2 is, do you know how? Look at the addition table in box A on page 412. So all of you have it in front of you. So, and I have a book in front of me, so I'm going to look like on my end, you flip through as I'm going over this. So you should turn to the addition table in box A on page 412. What pattern do you see in the highlighted sums? Explain. And I kind of already went over like the highlighted sums. And in this case, they're talking about like for all of the white sums, those are all going to be even. And all of the ones that they highlighted in green are going to be odd. So what pattern do you see in the sums? That they're all odd for all of the green shaded in parts. And then when you add an odd number of things to even numbers, there will always be an odd number of things. So even if they're adding the 2 and the 1, you're still getting a 3. And if they're adding the 6 and the 1, you're still getting a 7. So they're adding an even number plus an odd number. So the pattern that I see again, all of the numbers shaded in are odd. I'm going to erase this, hopefully quickly. Okay, now we're going to move down for the independent practice. For numbers 3 through 6, again, it's going to be more of just giving the answer. And I may just be saying them out loud instead of writing the entire explanation. So for number 3, it says to look at the sums that are shaded the same color. Describe a pattern shown by these sums. Explain why this pattern is true. So if I were to look at the dark purple sums, they're both 6. So the pattern that I see is that the sums of the same color are the same sum. They're the same number. Why? Because the numbers I'm adding to get those sums are the same. For the 2 dark purple 6 boxes, I add a 4 and a 2 for both of them. The add-ins, the numbers I'm using to add are not changing. And also the pattern can show the commutative property because it doesn't matter what order I add them in, whether I add the 2 plus the 4 first or the 4 plus the 2. Either is fine. For number 4, it says find other sums with a similar pattern, shade them on the table. So this is where you could have shaded in, and this is where I'm going to go in with my marker or my little pen. And I'm going to shade in the 8 right here and the 8 right here. But this is for number 4, okay? So, and I don't have to find more than one. I found 2 other sums. they're both 8, and explain why you chose those sums. I chose them because I can still show the commutative property, because for this 8 right here and this 8 right here, I'm still adding a 5 and a 3 and a 5 and a 3 for both of them. Okay, so just like the rest of the ones that they had shaded in, I was adding a 5 and a 3 to get both of those 8s. For the bottom part, it says, for number 5, shade the table to show a pattern you see. Describe your pattern. So I'm going to just draw a line through the pattern that I'm going to select, and I'm going to go this way. So my numbers are 4, 6, 8, 10, 12, and 14. And the numbers on the diagonal that I drew a line through, they can be found. I can keep going by skip counting by 2s. Okay, that's it. If I add 2 to 4, I get 6. If I add 2 to 6, I get 8. 2 to 8, I get 10, and so forth and so on. And if the addition table were to go up any higher than 9 downward, you'd be able to see that as well. And across also, larger than 7. And then explain why your pattern is true. For mine, the numbers increased by 2 because both addends increased by 1. So using the numbers in blue, my number here is 4 and 0, I get 4. 1 more than 4 is 5. 1 more than 0 is 1. So I get another one here and another one here. 1 plus 1 is 2. So I'm going up by 2s, what kind of looks like a Z, each time. So I know I said last time I wanted to make this video shorter. I think this one actually is longer. So I apologize for that. Hopefully this made sense. And again, I'm not going to go over the math and practices and problem solving in any of the videos I'll be posting. And if you made it to the end of this video, congratulations, you're here. I hope that hopefully it makes more sense now if it was confusing you before. And if you did make it to the end, which means you're still listening right now, have mom or dad message me that you finished watching video 8-2 or lesson 8-2, however they want to say it. Either text message me on Remind, email me, and you will get 4 points of credit for your math grade. Okay, well, thanks guys, and stay tuned for video 8-3. Okay, bye.